I want to do a class of problems called initial conditions. Before we do, I did want to show you one other way you may need to rewrite functions. I kind of ran out of time on the last video. Suppose I have a function, the integral of sine x over cosine squared x. Suppose I were to rewrite this as the integral of sine x divided by cosine x times 1 over cosine x dx. All right, this is the integral of tangent x times the secant x dx. Now, I know from my table, which we've memorized, that this is secant x plus c. Now let's go on and talk about initial value problems. Initial value problems are really exciting and quite a bit of fun. Suppose I tell you I have this class of curves and the dy dx is minus 2, it is 2x squared minus 1. And I'm going to tell you it goes through the point 0, 4. Well, it would be fairly straightforward for you to go ahead and find the class of functions. Y, I'm going to do it like this. And I'm going to integrate. So y is the integral of 2x squared minus 1 dx. I'm going to rewrite this. So this is 2 times the integral of x squared dx minus the integral of 1 dx. So this is 2x cubed divided by 3 minus x plus a constant. But now I want a specific value. I want one particular solution. And I want it to be, I want it to go through the point 0, 4. So I know that when x is 0, my y value is 4. So a lot of times we write it like this. So f of 0 is equal to, that's going to be 0, 2 times 0 cubed over 3. You don't have to do this. So f at 0 is just my constant there. And I know that that is equal to 4. So my particular solution here is y is 2x cubed over 3 minus x plus 4. Now, let's try and find a particular solution here where I tell you what the antiderivative is, or the derivative is 1 over x squared, and I'm going to define this for all x positive, and I tell you I want the function to equal 1 at 0. Or when x is 1, the function is actually equal to 0. All right, so f of x then is going to be the integral of f prime of x dx. So this is the integral of 1 over x squared dx. Let me rewrite this as the integral of x to the negative 2 dx. And this integral, you raise the power by 1, so it's x to the negative 1 divided by negative 1 plus a constant. So I know that f of x is equal to minus 1 over x plus c. And now I'm going to come up here and I'm going to use my initial functions. I know that f of 1 is equal to 0. All right, so when x is 1, so this is negative 1 over 1 plus c, I know my function is actually equal to 0. So this tells me c is equal to 1. So my particular solution is f of x is equal to minus 1 over x plus 1 for x that is positive. Now, go to your notebook, see if you can solve this problem, and come back. Now, Those of you taking physics are really going to love this because you have already done this problem. Now we're going to derive your free fall kinematics formulas from scratch. Suppose I have a ball thrown upward with an initial velocity v naught from a height h. How can you find the position function and height of the height, and how can you determine when the ball hits the ground? Now we're going to assume the acceleration due to gravity is minus g. Now, you remember the acceleration is the second derivative of position. And we know that this is equal to minus g. So let's do that. Let's integrate to get my velocity function. And let me go on and, not s prime, just s of t, is position. Now you remember, if s of t is position, s prime is velocity, and s double prime is acceleration. So, if s double prime is a, then s prime is the integral of minus g dt. So when I integrate this, what do I get? I get this is minus gt plus a constant. Now, I know at t equals 0, it has an initial velocity of v naught. At t equals 0, s prime of 0 is v naught. That's what the whole initial thing is. All right, so I'm going to plug this in. V naught is minus g times 0 plus c. So that tells me my constant is v naught. So my velocity function, which I'm calling s prime, is minus gt plus v naught. Now you probably memorized v naught minus gt. Now I want my position function. Let me switch pen colors here for you. My position function, s of t, is going to be the integral of s prime of t dt. So this is the integral of v naught minus gt dt. Doing this integration, this is v naught t minus g t squared over 2 plus c. So what is this? This is v naught t, minus gt. I'm sorry about that. Now, I know at t equals 0, I start out at an initial height, h. So h is equal to, well, this is going to be 0, that's going to be 0. H has got to equal my second constant. And yes, you should give these different titles here. So s of t is equal to your initial height plus v naught t minus 1/2 gt squared. Is that looking at all familiar to what you did in physics? All right, here you go. Try this one. When you're done, stop the tape and finish your homework.